Hi, today we are going to review some of the most important ideas in chemistry: atomic structure, isotopes, subatomic particles, nuclear chemistry, and metric unit conversions. These topics show up in almost every chemistry unit, so understanding them clearly will make the rest of the class much easier. I'm going to explain each idea in simple terms, give an example, and also show you how to solve the common types of problem you will see on quizzes or tests. Let's get started with atomic structure. What is an atom? An atom is the smallest piece of an element. Inside every atom, we have three subatomic particles: proton, neutron, and electron. Proton has plus one charge with a mass of 1 AMU in the nucleus. Neutron has a charge of 0 and mass of 1 AMU in the nucleus. And electron has negative 1 charge with a mass of 0 AMU outside the nucleus. So think of proton and neutrons as the heavy center, and the electron as tiny particles moving around in a cloud. So atomic number. So the atomic number is equal to number of proton. So carbon has atomic number 6, which is 6 proton. Oxygen has atomic number 8 in the periodic table, which is 8 protons. If the atom change the number of proton, it becomes a different element. So proton number never change in normal chemistry. So practice. How many proton does an atom with atomic number 17 have, which is 17 protons? Mass number. So the mass number is equal to proton plus neutrons. So if you know the mass number and the neutron, you can find protons. So proton is equal to mass number negative neutrons. For example, phosphorus 31 has 31 as a mass number and 16 neutrons. So 31 negative 16 equal to 15 protons. Let's move on to the isotopes. So isotopes are atoms of the same element with the same number of proton and different number of neutron. For example, carbon 12 and carbon 14 both have 6 protons, but they have different neutrons. So for practice, how many proton does every isotopes of oxygen have? Which is 8. So let's move on to the electron in neutral atom. So a neutral atom has electron equal to protons. For example, sodium has atomic number 11, so which is 11 protons and 11 electron in neutral form. Practice, how many electron in neutral chlorine have, which is 17 electron. So let's move on to ions. When electrons are gained or lost, atom became ions. So more proton than electron means positive ion, and more electrons than proton means negative ion. For example, 15 protons and 18 electrons are electron heavy, which is negative 3 charge. And let's move on to the isotope notation. So mass number is on the top, which is right here, and the atomic number will be on this bottom, and the charge is will be on right here. So let's move on to the average atomic mass. So on the periodic table, the atomic mass is an average of all isotopes. So for example, element has 25 percentage of 40 AMU and 60 percentage of 42 AMU and 15 percentage of 45 AMU, and we have to multiply each mass times abundance. We have to convert the percentage to decimal. So 25 percentage as a decimal will be 0.25. So we have to multiply everything. So 40 times 0.25 is 10. And 42 times 0.6 is 25.2. And 45 times 0.15 is 6.75, and we have to add them together, so which is 41.95 AMU. So for practice example, isotope X 75 percentage at 70 AMU and isotope Y has 25 percentage abundance at 72 AMU. So the answer would be 70.5 AMU. So let's move on to the nuclear chemistry. Now let's look at nuclear decay. There are three common types: alpha, beta, and gamma. So for alpha decay, alpha particle is 4 mass number and 2 as an atomic number. So when an atomic number or mass goes through alpha decay, it becomes negative 4 mass and negative 2 atomic number. So for beta decay, when the formula is 0 as a mass and negative 1 as an atomic number. So when an atomic number and mass goes through when an atomic number goes through the beta decay, it becomes plus 1. When mass number goes through beta decay, there is no change. When for gamma decay, when atomic number or mass number goes through, it has no change. The formula is 0, 0. There is no mass change and no atomic number change. So let's look at an example for alpha decay. So 238, 238 and 92. 238 is a mass number and 92 is an atomic number. So when it goes to alpha decay, it becomes negative 4 and negative 2. So we have to subtract 238 negative 4, which becomes 234, and when we subtract 92 negative 2, it becomes 90. So for example, for practice, oops, 226 is a mass and 88 is an atomic number. So when it goes to the alpha decay, it becomes 222 and 86 Rn. I did Rn because for 86 is an atomic number, right? So we have to figure the 86 on the periodic table, so which is Rn. So let's move to the beta decay. So beta particles is 0 atomic mass, mass number, and negative 1 as an atomic number. So when the mass number, which is 3, goes to the beta decay, which becomes 3, because there is no charge on the mass. When when 1 as a atomic number goes to the beta decay, it becomes 2, because minus 1 goes like plus 1 for beta decay, which becomes 2. For practice, the atomic number is 55, so we have to add plus 1, which is 56. And for a mass number, there is no change, so we just have to do 137. So which is 137 as a mass number and 56 as a atomic number. So when you find 56 as on a periodic table, it is barium. So the symbol is Ba. So for radiation shielding, alpha is stopped by a paper, and beta is stopped by a plastic or wood, and gamma is stopped by a thick lead or concrete. So let's move on to metric conversions. So example 1. So Oh, these are the meters that you have to memorize. So 1 centimeter is 100 millimeter, and 1 nanometer is 10 to the power of negative 9 meter. So 1 micrometer is 10 to the power of negative 6 meters. So you have to memorize this for this exam. So for example, 550 nanometer, we have to convert to the meter. So I did this. So 550 nanometers, and one we know 1 nanometer is 1 times 10 to the power negative 9 meter. So nanometer and nanometer will cancel it out, and we left with 550 times 1 times 10 to the power of negative 9. So when we multiply that, it it becomes 5.5 times 10 to the power of negative 7 meters. So I provide the answer right here. So we did 550 nanometer, and we know 1 nanometer is 1 times 10 power to the power of negative 9 meter. So nanometer will cancel it out, and we have to multiply this, and we have to divide by 1, which is the answer of this. Then we have to convert centimeter to millimeter. So we know 1 centimeter is 10 millimeter. So centimeter and centimeter will cancel it out, and 9.53 times 10 will be 95.3 millimeter. And we have to convert 7,800 to meter. Actually, this is micrometer. So the micrometer symbol will look like this. So we know 1 micrometer is 10 to the power of negative 6 meter. So micrometer and micrometer will cancel it out, and we left with 7,800 times 10 to the power of negative 6, which will give me 0.0078 meter. So let's move on to the ion and isotope notation. So for isotope notation format, there would be mass number, element symbol, and atomic symbol. Atomic number. So for ion, add charge. For example, sulfur with 16 protons and 16 neutrons and 18 electrons with a mass of 32. So when we have to find the mass, we have to add protons and neutrons, which is 32. And we have to find the charge as well. So for charge, so so for charge, we know more electron than proton is negative ion. So this would be negative 2. So the symbol will look like 32, 16, and this would be yes to negative 2. So we find the mass number by adding protons and neutron, which is 32, and we find the protons, which are also already given, and we find the charge by, which is like, which is more electron than proton is negative ion. If it is more proton than electron, which is positive ion. So this is negative ion, which is negative 2. And so in this lesson, we covered atomic structure and subatomic particles, isotope and average atomic mass, ions and charges, periodic table positioning, nuclear decay, alpha, beta, gamma, and shielding radiation, and dimensional analysis and metric conversions, isotopes and ions notations. So this idea formed the foundation of for all higher level chemistry. So understanding this basic will help you solve problems quickly and confidently.